differentiate this, I have 2x and then x cubed plus 1 to negative 2/3 and plus x squared times negative 2/3 times x cubed plus 1 to negative 2/3 minus 1 times the inner function prime. Okay, one more time. 2x, that's correct. This is plus x squared. Negative 2/3 minus 1. Yes, negative 5/3 times the inner function prime 3x squared. Okay. Good. Okay. I'm going to have to write it again. So 2x, x cubed plus 1 to negative 2/3. So at least the 3 will go away, fine. And then I have x squared with x squared, so this is x to the 4th and minus. So minus 2x to the 4th, x cubed plus 1 to negative 5/3. Gee whiz. So 2x, x cubed minus 1, plus 1 to negative 5/3. If I don't factor out, I'll be in trouble. So 2x is out from negative 2/3, we subtract negative 5/3 and we get 1. 2 is out, so minus x cubed, and this is all out. Really? Really? Okay, let me see one more time. 2x, I factored out that. The 2 is out, x cubed is in, this is 1. And from negative 2/3, we subtract negative 5/3, we have 3 over 3, which is 1. Look at that. I would have never expected that. But 5/3 is the cube root of x plus 3 to the plus 1 to the 5th. So this can be positive or negative. So here I cannot conclude. This one can be positive or negative as well. So this is not going to be an easy ride. We have to check. So what I would like to do is put this function in the graphing calculator. And let me see if so one more time. So to the left, this will be negative, and this will be negative. So this must be positive. Let's see if we need to do that. If I plug in 5, but of course this can be 0, right? If I plug in 5, everything is positive. And if I plug in negative 0.5, it will be negative. We don't need anything. Good. So opening up, opening down, opening up. We will find mistakes in a blink when we graph it. So from negative infinity to 0, okay. No, I don't like my signs. I don't like my signs here. Negative 5 with negative 5. But this is correct. Oh yeah, because it's undefined. Okay, I'm checking again. With negative, with positive 10 is clear this. Okay, well, we'll see. Now I don't need anything else. Just my table. Everything else can go away. That's all I need. Okay. So at negative 1, the function is 0. At 0, the function is 1. And now let's see. It's coming from, so here, okay, so there is an inflection point here. There are no max min. The function is increasing all the time. Opening up, we'll see in a moment. Opening down and opening up. Okay, so that's what I have so far. So it's coming from negative infinity, opening up, increasing. Okay. Here, it changes concavity, okay, and goes to the inflection point, opening down, still increasing. Okay. So because the derivative does not exist here, it's clear why. Because of a double tangent. Okay, then opening down, getting to 0, 1, where it changes concavity, increasing. Okay, fine. Going to positive infinity. For a moment, I thought it was just a little bit weird, but it works. And yes, especially in a test situation, I highly recommend plugging in the function and double check. Just make sure that that you have no errors. I don't have doubts, but I like to look at the graphing calculator as well, somewhere between -5 and 5 and +5 and 5. I'll change the viewing window. So I like to present it like this. It's up to you how you want to put it in. And then +1. And everything to power 1/3. Again, this is my preference. You don't have to use this. You have other options in the math here with the cube root. Okay, and now I would like to change the viewing window because I see the action is anywhere between -5, 5. So why bother? -5, 5, even less, but that's okay. And -5, 5 with a scale of 1. So when I click enter, I have to see the graph of the function opening up, then opening down, and then opening up to infinity. If I don't see that, then I'll say oops. So let's take a look. So exactly what I expected. Of course, the calculator shows here that vertical tangent or double tangent, something like that. So opening up, opening down, and then opening up. If I zoom in, it will look a little bit closer to what it should really look, but you should always do this. You don't want to lose any points on a test or final exam. It was a very interesting problem. Thank you for choosing that. So the function is always increasing. There is an inflection point. This cannot be an inflection point because the derivative is undefined. So it's either double, because it's undefined, it's a vertical tangent, clear, yes. Undefined means vertical tangent. And the point exists. And as we had it here. So maybe I should emphasize that a little bit more. So it shows like a vertical tangent. Good, very good pick. A very interesting problem. Oh, I forgot. So y equals the cube root of x cubed plus 1. We always have to write the function on the coordinate system. Good. Where is my book? Okay. Very interesting. It was a nice function. Anything else? Do we want to look at anything else from our? Yes.
Can we do a WebAssign from
Yes.
4.7?
Yes. 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 I'm ready. Anything.
Okay. It's number 7 in 4.7.
Give me 1 second. Let me write 11. Yes. Sure. You said number 7 from
4.7.
Okay, I'm ready.
A rectangular storage container without a lid is said to have a volume of 10 meters cubed. The length of its base is twice the width. And then
so the length of the base is, so it's a rectangular.
Twice the width. Yes.
Okay, so the length, so if this is x, this is twice x. Okay, good.
Material for the base costs 15 per square meter and the sides cost 9 per square meter. Find the cost for the least expensive container.
Good. Perfect. So minimize cost. Awesome. Very good problem. Thank you. Good. So first of all, I start with what I have. I have the volume. Remember, I have to build this function. I don't have the cost function yet. So the cost function, maybe let's start with that, cost. The cost of the base is 2x times x, so 2x squared multiplied by the price per square meter, plus we have 2 identical and 2 identical. So this is h. 2x times h twice, so 4xh, plus x times h twice, 2xh, everything multiplied by 9. So let's review what I just did. The base is length times width, 2x squared, times 15 per square meter. Here, now, we have 2 sides that are identical, x times h times 2, and 2x times h, this front and the one back, 2x times h times 2, 4xh. I add this area, but I have to multiply by 9 per square meter. This is the cost function, and it only has one problem. This is the problem. Because I have a function with 2 variables. But this problem will go away when we analyze this. That's why this is given to us, to eliminate h. So the volume of such a box is 2x times x times h. So 2x squared h. And we know that 2x squared h must equal 10. So from here I'm going to remove h. So h equals 10 divided by 2x squared. I'll simplify, and I'll say h equals 5 over x squared. And this will go in here, and will go in here. So now the cost is indeed a function of x only. 30 x squared plus 4xh plus 2xh is 6xh. 6x times h times 9. I will simplify by an x. I can simplify, I can continue with 30x squared. This is 30. 3 times 9, 270 over x. So I have the cost function. Here it is. All I need to do is the whole thing now. C prime of x, 30 times 2x minus 270 over x squared, which is 60x minus 270 over x squared. And yes, this is the easiest way because you need to study the sign. So 60x to the third minus 270 over x squared. It's never undefined because x cannot be 0, but c prime of x can be 0 when 60x cubed minus 27 is 0. And there is only one real solution here. Stop me if you have questions, please. So this is page 12. So x cubed is 270 over 60. There is nothing I can do really here. So it's the cube root of 27 over 6. I can write it as 9 over 2. It's not going to make any difference. 9 over 2, 4.5. I don't know what this gives. Nobody knows. We will in a minute. So c prime of x and c of x. Okay. When I plug this, and then the denominator means nothing to me, so when I plug in 0, it's negative. Now this is guaranteed to give a minimum. I don't know if we're asked, are we given decimal digits, approximation, or they want exact, or how does this work? What does they?
Nearest
Says
cent.
round to the nearest cent.
Okay, so they want the minimum cost. They want X or the dimensions and the minimum cost.
Just the cost.
Just the minimum cost. Okay, good. So in order to find the minimum cost, I have to plug in the function, this cube root of, one more time, I simplified by 3. Yes, 9/2, correct. Okay, so I go to the graphing calculator, and in y equals, where is my function? It's 30x squared, and then plus 270 divided by x. And I want to plug in the cube root of 4.5. That's not what I meant. Okay. 245.31.
Okay, can you go, I guess, stop screen sharing and then go back a step? I wanted to ask about
Yes.
something on the previous page.
Yes.
When we went from 60x minus 270 over x squared to 60x cubed, that was same, the common denominator, right? That's
Yes.
what happened, u times 60.
Yes.
Okay.
Because otherwise I can't solve, I cannot set it equal to 0. I have to have it in
Right.
the fraction format to say a fraction is 0 and the top is 0.
Right, okay.